So today we're going to be doing an experiment in which we find the spring constant of this spring using two different approaches. The static approach, which is Hooke's law, which we've used before, which I'm going to show you very briefly and I'm sure you're familiar with, and then making use of the relationship between the spring constant and the time period of the oscillating spring when it's got some masses on it. So we'll begin using Hooke's law's approach. And the first thing to do is to decide the length of the spring. Now you can measure from this point here, or you can measure from this point here, but you need to be consistent. So I'm just going to use the part here, and I have got a length of my spring of 2 centimeters or 0.02 meters. The earlier we convert into meters, the better. That's my original length before there's any mass applied or force applied. And I'm going to deduct that original length from each one of my measurements of the length as I increase the mass that's on it. So I'm going to start with 0.1 kilograms, and my spring has gone from 2 centimeters now, or 0.02 meters, to 5, to 0.05. I will record the results into a spreadsheet which I'll send at the end of this video. 200 grams now, or 0.2 kilograms. And we have got 9 centimeters. If you want to measure this more precisely, you could use a piece of card going across here at this point. And again, make sure that you are approximately at the same height as the measuring point you've got to avoid parallax. 19 centimeters. One. Six. I will do one more. 29. Now, if I take that data and plot it in a graph, I'm just going to use Excel, but obviously you are going to use you're going to use a hand-drawn graph. If we have a look at that data, It's not a bad straight line, it's not perfect, but we can definitely see the line there. I've got force plotted as the y, force as the x and extension as the y. If I reverse those two, which is not traditional to have the independent variable up the side, then I can use the gradient is the spring constant. As it stands, I would have to do 1 divided by the spring constant. 1 divided by the gradient to find the spring constant. So that's one approach.